Hello guys, so today we will discuss chapter number 6 part 2 IPsec protocol. If you guys remember, in the first video we discussed definition of IPsec protocol, what exactly the IPsec protocol is. We also discussed security associations, IPsec architecture, and modes of operation, tunnel and transport. So today we are going to continue. We are going to discuss authentication header in detail, the modes of operations, like we'll see how we can implement authentication header in transport mode and in the tunneling mode. And then we will also discuss ESP in detail. So what are these protocol actually? If you remember IPsec protocol, it's the network security suite of protocol which provides confidentiality, authentication, and integrity. So it provides mainly three things: confidentiality, authentication, and integrity. For confidentiality, it uses ESP protocol. And for authentication and integrity, it uses authentication header protocol. And that is why we call IPsec is a suite of protocol. Why? Because it involves two protocols further to provide confidentiality, authentication, and integrity. ESP, it mainly involves encryption schemes. It could be symmetric, it could be asymmetric to provide confidentiality, while authentication header mainly involves authentication systems like digital signature, maybe HMAC, maybe message authentication code, maybe hashing and stuff like that to provide authentication and integrity. So in our today's video, we're going to talk about authentication header, implementation scheme, and ESP in detail. Just to give you a quick overview of what we discussed in the last class, and then I think it would be easy for you guys to understand what we are going to discuss today. So IPsec protocol, it's a suite of protocol which runs on TCP/IP protocol, and it's optional. Like, it's not mandatory that you have to use IPsec protocol unless you want a network security, like a packet level security. If you want a packet level security, IP packet level security, then we have to enable over IPsec protocol, which is a part of your TCP/IP protocol. So what is TCP/IP protocol? TCP/IP protocol is a suite of protocol which allows the computers to communicate with other computers over internet and over the network. And there are four layers on TCP/IP protocol: application, transport, internet, and network layer. So application layer, like all these applications which you guys can access or which you can get done through your browser, runs on application layer. For example, to send an email, we use SMTP protocol. Port number 25 mainly use FTP to upload and download service. HTTP, HTTPS, I believe everybody's well familiar to display how the page will be displayed. So for example, if you just open your browser and you just type, for example, google.com, okay, and you just want to visit google.com. So what happens actually when you open your browser, type this thing, HTTP header has created. And what is HTTP header? It's a request. Like, I want to access this protocol, HTTP protocol, for example. When the packet gets to transport layer, over the transport layer, they will add two things: TCP header plus the data. TCP header will define the port number. Like, based on the service, they will add the port number, like source and destination port number. For example, if it would be HTTP port, source port number is 80 and destination is also going to be 80. Then data, like that's the actual payload which you have transmitted. Let's say if it would be uploading, so that would be a data, it would be a request, so request data. And then HTTP header will carry forward. When this packet will get to internet layer, then we will add IP header, and over IP header we add source and destination IP addresses. So you got source and destination IP addresses, we got source and destination port numbers, and data, request data, and this is type of the request, or you can say the protocol. Next, when this packet will get to the next layer, which is network layer, we can add Ethernet header, which is source and destination MAC address. In fact, the gateway MAC addresses. So this is complete over TCP packet, which have HTTP header, type of request, the payload, source and destination port numbers, plus break down the data like sequence number and all that. I believe everybody's already familiar with that. Source and destination IP address and Ethernet header MAC addresses. Now, for example, over the internet layer, there is ICMP protocol, which ping and trace out these services. It supports these two services. Other than that, IPsec protocol also run on internet layer. So if you want a security, we can actually use IPsec protocol here. Now, if you use IPsec protocol, it will provide you packet level security like confidentiality, integrity, and authentication that we already talked about. If you enable IPsec protocol, what's going to happen? Now, this packet, before getting to network layer, they will add another header here. So like this packet, before getting to network layer, this packet will look like this. Everything else will be same. So IP header, if it would be implemented in the transport layer, if you remember the transport layer where we inject the packet like the IPsec packet, IPsec header will be added after the IP header. So everything else will be same. TCP data will be here, or the payload, and HTTP header will be here. So in the transport layer, IPsec header will be injected here after the IP header. While if you implement in tunnel mode, like the VPN thing, so what's going to happen? We will encrypt everything, because whenever you inject or inject the IPsec header, everything after that will be encrypted. So if you inject IP header, IPsec header before the IP header, like right here, so IPsec header will be added here. So IP header, like everything else will be encrypted. Like you are basically putting the packet before that IPsec header. So everything else will be encrypted. We already talked about it. So transport mode is basically where we inject IPsec header after IP header. IP header will not be encrypted. While in tunnel mode, IP header will also be encrypted. And of course, it will be, if IP header will be encrypted, we don't know what is source and destination port number. We have to add another new IP header. This is what we discussed in the last video. Please do watch the last video if you're still struggling with this thing. Okay, please do let me know if you will have any question. So let's get back to over the IPsec protocol. And as you know, in IPsec protocol, there are mainly two things that it does. It mainly use authentication header, and it also use ESP. ESP for confidentiality, where we uses encryption, decryption protocol. AH for authentication plus integrity. We already talked about it. So let's come back to over today's agenda. So now let's see authentication header, how to implement authentication header in IPsec. So this is basically what authentication header packet, or you can say header, looks like. So what is authentication header? Firstly, as you know, authentication header provides two things. It provides two things. It provides packet integrity, like the packet has not been modified or tampered during communication, and it also provides authentication. Okay. So authentication means message is coming from the right person, from the right source. That's basically what it provides. Please remember, authentication header does not provide any confidentiality. So no confidentiality. Why no confidentiality? Because there is no encryption, decryption, nothing like that. No confidentiality will be achieved through authentication header. Only authentication and integrity. So this is basically what the authentication header packet looks like when you inject. Like when you inject this authentication header, for example, so this is basically what's going to actually add right here in IPsec header. I will explain you. So it has 32-bit field, and what it has next header, payload length, reserved, and all these stuff. Let me give you detail one by one. So let's say the first thing is next header. So next header will define, like this particular field, what it will define, tells about the next header, like next header. It could be authentication header, it could be ESP header. It has the information about the next header. So info about the next header. So info about the next header, that's basically what it has. Nothing special. It doesn't have information about this current packet. It has information about the next upcoming header, like the header which is before that, like another header. It based just to connect these two packets, in fact. Next is the payload length. As name suggests, payload length. Payload is basically our data, and it basically tells the length of the payload. Length of payload. Payload means the data to be transmitted. Next is going to be reserve field. Reserve field, as you already know, reserve field, it's a reserve. We don't use that. It's for the futuristic approach, like for future extension. This is for future extension. Future extension. Like if there would be anything new, for example, fields need to be introduced, we will put down here. Next is the SPI, security parameter indexed. If you remember, it's the ID of the security association. security association with which this packet belongs to, like this particular header belongs to. So it is the ID of security association with which this packet, this specific packet belongs to. Next is the sequence number. You already familiar with the sequence number. As you know, on the transport layer, at transport layer, we divide the packets into chunks. So it will define the packet number for which we are putting this authentication. What's the packet number? This packet number plays a very important role, or like sequence number, to avoid the replay attacks. Remember the windows like checkbox and all that, it's basically help for that. The last thing which is very important, that's authentication data. So authentication data, it is basically something that's basically which provides you authentication. Provides authentication and integrity. For integrity, typically we use ICV. It's basically integrity check value. Integrity check value for receiver. Check value. And typically we use here checksum. Checksum, I believe some of you guys might heard of checksum. If not, then we will discuss that in detail in class. For authentication, we use authentication protocols like it could be HMAC. You can use digital signature. We can use MAC. We can use hashing, depending upon it's the prerogative of the network developer or the network administrator, what kind of authentication header or authentication protocol they want to use. So this is basically what is authentication header in all these fields. Now let's see how we can implement authentication header inside the IPsec protocol. Okay, let's see. For example, this is our TCP/IP protocol, IPv protocol having IP header. Remember IP header, source and destination IP address. TCP header, source and destination packet data, that's the payload. And of course, after that, there is HTTP request and other stuff like that, because IPsec runs on internet layer. On internet layer, this protocol actually runs. So I didn't put the HTTP header, otherwise the packet will become too big. This is IPv4 and that's IPv6 packet. IPv6 packet is exactly same, but we just have one new field, which is called extension header. So extension header, I believe you guys heard of extension header in the networking course. Extension header is basically, it has some supplement information used by the network devices like routers, switches, like the routing map and the other protocols, like which protocol they use and all. So extension header has supplement information used by network devices. Okay, network devices like router, switches, endpoint host, and what kind of information, like the routing protocol, routing algorithm, routing map, and stuff like that. That information is stored inside the extension header. And this header is not present in IPv4. Okay. Now let's see, for example, this is our, we just want to implement, let's say, authentication header in IPsec. So before authentication header, this is basically how IPv4 packet look like. And this is basically how IPv6 packet look like. Now at the transport mode, if you remember in the transport mode, what we do is, we inject IPsec header after IP header. So IP header will not be encrypted or will not be affected. So we will actually put the packet right down here. After the IP header, okay, right after down here. So let's see how this particular packet will look like. So for IPv4, what's going to happen? This is the packet. So in IPv4, what we're going to do is the IP header will look like same. IP header will be here, but on internet layer, we will put a packet IPsec header and let's say authentication header. We are going to put authentication header. So after that, what's going to happen next is the TCP packet will be here and the data will be here. It is not encrypted, but this TCP data and authentication, the data will be authenticated. So this is basically how the transport mode IPv4 look like. Now, for example, for IPv6, what's going to happen? So we will actually inject the packet right down here after extension header. So now something like that, this packet will look like this. So IP header will be same, extension header will also be same, extension header which has the network device information, then authentication header, and whatever will come after authentication header will be authenticated. Okay, so TCP packet, the TCP header will be authenticated and data will be authenticated. So this is basically the transport mode. Okay, where we inject the IPsec header. In our case, this IPsec header is authentication header, will be injected after the IP header. Okay, source and destination address will unchanged, end-to-end communication. While in the case of tunnel mode, if you remember, in the tunnel mode, we inject IPsec header. We inject IPsec header before IP header, and IP header will also be authenticated. Okay, IP header will also be authenticated in the tunnel mode. So what's going to happen now here if you actually revise this thing with the tunnel mode? So what's going to happen? The packet will go up here. So now let me show you how IPv4 look like now. So in IPv4, what we are going to do is we are going to put the authentication header before IP header. So IP header will come after here, and then TCP header, then data. So now what happened? Everything else same, but we put the authentication header before IP header. So if you do that, of course, it will actually make some changes down here in IP header as well. Okay, everything will be authenticated. Now, what will happen if this IP header gets disrupted? How we can find the source and destination IP address, where to route the packet? So we have to actually add another packet here, which is new IP header, which will define the source and destination, like the gateway IP addresses. That's the tunnel mode. Like everything will be authenticated, which will come after authentication header, including IP header as well. Same is the case with the IPv6. Everything else will be same. This authentication header will be padded before this. Like right here, we will actually put that right here. So let me draw this down here. So it is the IPv6. So what will happen? Authentication header will come here. After that, IP header, the original, then extension header. After that, we will have TCP header, then we will have the data. Now the problem is, since it's a IPv6, so before authentication header, what do you think what will come? So before that, new IP header, because the data will be get tampered, or you can say modified. The IP header will be automatically modified. So new IP header is required, plus new extension header, which will define the which will store the information about the new devices, new extension header, because it's an IPv6 packet. So IPv6 packet should have these two fields. You can see these two fields should be here. So that's basically, these two fields will be added before authentication header, and rest of the things after authentication header will be fully authenticated. So this is basically how it's going to be implemented in both transport mode and in the tunnel mode. Next is the ESP encapsulating security payload, and which provide confidentiality, which involve encryption and decryption schemes and everything for confidentiality. ESP, the benefit of ESP is it can be implemented in two modes: with authentication or without authentication. So with authentication mean we will use the authentication algorithms along with the security confidentiality algorithms, and without authentication mean we will just provide confidentiality, no authentication and integrity of the packets. This is basically how this ESP payload header looks like. This is basically, these are different parameters, SPI, sequence number, payload, and some other stuff. So the first thing, let me explain you guys this SPI, security parameter index. Absolutely the same thing. It's basically the ID of security association with which this packet belongs to. with which packet this particular packet belongs to. Okay, that's basically what SPI is. Next, sequence number, I believe the same thing that we already talked about. It's basically the packet number. It defines the packet number for which we are providing this confidentiality. Payload data, it defines, I mean, that's very interesting now. This particular payload data is the actual data in encrypted form. This is basically where the data will be encrypted depending upon what kind of, whatever the algorithm you use. So it will encrypt the data which you want to transmit. This data will be encrypted. So it will have your encrypted data. So data will be fully encrypted down here. Plus there is a padding thing. Why do we need a padding? Padding is basically, for example, let's say if your data is of 32 bits, and let's say if you want to use, for example, RSA algorithm, and I'm just assuming that RSA, for example, requires 64 bits of the plain text. So what we're going to do is we will use this padding and add zeros on the left side to make it compatible with RSA. Getting a point? That is basically why we use padding, to make the payload compatible with the algorithm. So to make it compatible with algorithm. So we will actually pad zeros on the left side. I believe everybody knows that why we pad the zeros on the left side. Of course, remember, otherwise, if you pad the zeros on the right side, it might change the numbers. Pad length, which will define how many pads you have used, and the next header defines how the next header is going to be. Last is authentication data. This is basically optional field. Optional. Why optional? If you use ESP with authentication, then we will have authentication data, like it will have the ICV, the integrity check value, then it will have the authentication algorithm as well. Authentication algo as well. Otherwise, if you are not using authentication, so of course there will be like this field will be empty. There will be nothing inside it. So this is basically what a ESP packet or ESP header looks like. That's basically what ESP header is. Okay. Now let's see the different modes of operation, like again tunnel mode and the transport mode. This is basically over two packets, IPv4, IPv6 without ESP. Okay. So before ESP, how the packet will look like, let's say IPv4 packet having IP header, TCP data, TCP header and the data. Same is the case with IPv6, it just have this extra packet which is called extension header that we already discussed. Now let's see in the transport mode what will happen. And as you know, in transport mode, we add the ECP or IPsec after the IP header. So IP header will not be encrypted. So now what's going to happen? IP header, if you add the authentication header, ESP header, let's see how it will look like. So the first thing is going to be IP header will be exactly same. IP header will be same. It will be not be altered. ESP header will come after that. And after ESP header, we will have the TCP like we have injected down here. TCP will come here. Data will come after that. Now, after that, there will be two more things. I'll explain you why we add those two things. ESP trailer and ESP authentication. Now, ESP authentication, this packet or this thing is optional. If you use ESP with authentication, then this packet will be here, otherwise not. Now, what will happen? After that, why we add the ECP trailer? ECP trailer defines or it tells, hey, this is basically, the end of the data. Like data ends here and this is basically ECP trailer, like end of the data and starting of the, just to differentiate between the data and ECP. So once you put ECP down here, what will be encrypted? TCP will be encrypted, data will be encrypted, ECP trailer will be encrypted. ECP authenticator will not be encrypted. It is just a authentication, like it's a digital signature, HMAG or whatever kind of things it's going to be. But it's optional as well. It's not required. But whatever comes after ECP will be encrypted beside ECP authenticator. Now, what will happen to IPv6? Everything else will be same. Now, what's going to happen? The authentication ESP will add it down here. Exactly the same way how we did that for the AH. So let's see. The first thing, of course, IP header will be same. Nothing is going to change down here. Exactly the same. Extension header, no change. extension header. Now what we will do on internet layer, we just add ESP header. So after ESP header, we got TCP because we are adding here the data just to define where the data ends, ESP trailer, and last is ESP authenticator, like just for optional thing. Now what's going to happen here, what is basically encrypted? So your TCP data will be encrypted, header will be encrypted, data will be encrypted, and ESP trailer will be encrypted. This part is going to be encrypted. And this is basically if you implement ESP in transport mode. Now tunnel mode will be very similar, but slightly complex. Why? Because here this overall packet is going to be treated as the internal packet, and we will add the ESP before that. Okay, let's see in the tunnel mode how it will look like. So everything else is same. Let me show you guys. So what we're gonna do is we will actually add ESP before that. So ESP will come here, and IP header, this IP header, before the IP header it will be added. Then TCP, then ESP TCP header, then we will get over data down here. And since you have added the ESP here, so after that, as you know, ESP trailer will come just to let them know, hey, this data ends here. And then ESP authentication here. Okay, now the problem is IP addresses got encrypted, so we need to add new IP header here. Okay, we need to add new IP header here. So what will be encrypted? Whatever comes after ESP, it will get encrypted till ESP trailer. Okay, now what will happen in the IPv6? Slightly extension. So in IPv6, what's gonna happen? Let me define you. As you know, in IPv6, this overall packet will get encrypted. And what we will put is we will put over the ESP before this. So let me just put that. So ESP will come here. After that, over IP header. After that, extension header, TCP and data. Extension header. Then we will have TCP. Then we'll have data. Since the ECP is here, just to define where the data ends. So ESP trailer. Then ESP authentication. Okay. Now the problem again, IP address got encrypted, extension header got encrypted. We need to put these two things here. So new IP header. Since it's IPv6, so extension header will be also here to define that is the IPv6. So what will be encrypted here? Whatever comes after ESP, all the way to trailer. So this is basically how the ESP can be implemented in IPv6 and IPv4 using tunnel mode, using transport mode, and that's basically all about IPsec security algorithm is. So if anybody has any questions, anything, so please bring it up in the class. Thank you very much.